Right, in this flip learning task we're going to be learning about Hess's law. Hess's law and enthalpy of formation. So by the end of the flip learning task you should be able to use Hess's law to determine enthalpy changes of reaction using something called an enthalpy cycle. Okay, just to give you an idea of where we're heading with this diagram down the bottom is Right, first we're going to have to understand the meaning of this term enthalpy of formation. So the enthalpy of formation is the heat energy transferred when 1 mole of a substance is formed in its standard state from its elements in their standard states. So if we take as an example formation of HCl in its standard states, in other words the state it would exist in at 298 Kelvin and 1 atmosphere pressure, HCl would be a gas, and the enthalpy of formation of HCl would be the enthalpy change when HCl is made from its elements in their standard state. So here we've got hydrogen in its standard state, which is gas, and chlorine in its standard state, which is also a gas. So in order to make 1 mole of HCl, we'd have to start with half a mole of hydrogen and half a mole of chlorine, because hydrogen and chlorine both go around in pairs. They're bimolecular. So the enthalpy change for this process would be delta H formation for HCl. Here's another example. So this time we're going to make 1 mole of ammonia, 1 mole of NH3. NH3 is a gas in its standard state, that's 298 Kelvin, 1 atmosphere pressure. Ammonia would be made from nitrogen and hydrogen, both of which exist as N2 and H2. So if we wanted to make 1 mole of NH3, we'd need 1 single nitrogen atom, which would come from half a nitrogen molecule, and we'd need 1.5 hydrogen molecules. So the enthalpy change for this process would be delta H formation of NH3. In other words, the enthalpy change when 1 mole of NH3 is formed in its standard state. Okay, so now let's explain to you what the purpose of Hess's law is. Okay, if we take this example, say we wanted to find out a value for the enthalpy change of reaction when ammonia reacts with hydrochloric acid to make ammonium chloride. Now, we could find out the value for that enthalpy change by using what's called a Hess's cycle or an enthalpy cycle. And an example of that is shown here. Let's explain how it works. The idea of this is that the enthalpy change to get from ammonium and hydrochloric acid to ammonium chloride will be the same regardless of the route that we take to get from the reactants to products, as long as the conditions of the reactants and products remain the same. So we could go by the direct route in which an ammonia molecule reacts with a HCl molecule to make ammonium chloride solid. But we could also imagine another route in which we go via the elements in their standard states down here. Let's explain how that would work mathematically. So, we're given some data over on the right hand side here. We have a value for delta H formation ammonia, which is minus 46.1 kilojoules per mole. That means that we know that to get from the elements, nitrogen and hydrogen, to ammonia would give out 46.1 kilojoules per mole. That's an exothermic reaction because it's got a negative in front of it. We also know how much energy would be given out when hydrogen and chlorine react to make HCl. That's minus 92.3 kilojoules per mole. So we actually have a value for the enthalpy change going from these elements to the element to the molecules on the on the left hand side here. We also know how much energy would be released when these elements react to make ammonium chloride. So we know that the enthalpy change of formation of ammonium chloride is minus 315 kilojoules per mole. That's to get from the elements up to the right hand side of the equation there. Let's put all that together. First I'll write the numbers onto the enthalpy cycle just here. So minus 46.1 kilojoules per mole, that was to make the ammonia, minus 46.1 kilojoules per mole. I'll leave out the units here. To make 1 mole of HCl, that would be minus 92.3. So on the other side we've got minus 315 kilojoules per mole to get from the elements to the ammonium chloride. Now, delta H reaction, that's the enthalpy change for the reaction at the top there, is going to be equal to the enthalpy change to go from these compounds on the left hand side back to the elements and then forward along this arrow to make the ammonium chloride. So there's a couple of golden rules when you're dealing with Hess's law. The first of them is that if you go backwards along an arrow, then the sign of the enthalpy change has to change. So to go from the elements to ammonia would be minus 46.1 kilojoules per mole. But of course if we went back the other way, it's going to be plus 46.1. Similarly with the HCl, to go from the elements to HCl would be minus 92.3. Changes to a positive. To go back the other way. Now we're going to go from the elements up to ammonium chloride. So that's going to be minus 315 kilojoules per mole. Okay, I'm working out the left hand side there, that's plus 138.4 kilojoules per mole, and minus 315 comes to minus 177 kilojoules per mole, with a bit of rounding. So what we've discovered is that the enthalpy change to go from ammonium hydrochloric acid to ammonium chloride is minus 177 kilojoules per mole, but we've worked it out without ever doing that reaction by actually using information that we do have about the enthalpy change of formation of ammonia, hydrochloric acid and ammonium chloride. And that's the idea of a Hess's law cycle. You can find out an unknown enthalpy change by going along a different route.